everyone, and welcome to the latest A Spotlight on interview. Today we're going to be talking about all things CRISPR and some of the more unusual applications where this is going to be like helping society in the future. So Monika, if you could just introduce yourself and tell everyone a little bit about what you do as well.
So hello to everyone. I'm Dr. Monika Paule, CEO and co-founder of company CasZyme, a gene editing company working with the CRISPR-Cas technology.
So I think it'd be good, obviously I think everyone probably watching this knows what CRISPR is, but I think it'd be good to kind of give everyone a little bit of an overview about kind of what CRISPR is and kind of where it came from, and we'll kind of go from there.
Yeah, I'm sure that most of the people listening to this know what CRISPR is and what great technology for genome editing. You know, I would say that let's describe a CRISPR like a real breakthrough technology which can make an impact for the society from so many points, you know, from humans to agriculture to all our industrial applications, that this breakthrough in gene editing that happened, well, almost, I would say, 10 years ago, can actually, you know, bring us a change, not only from scientific, but also from real commercial and social applications.
From its kind of first discovery, how do you think that kind of the scientific community's views and opinions on it have kind of changed? So from that initial kind of discovery to kind of now where people are kind of understanding the kind of applications of it a bit more?
Well, I would say that as all new things, at the beginning, society is scared, but also some part of it is very excited and maybe too excited, the same as the first part is scared. So I guess now we have much more understanding that, you know, CRISPR can really offer a lot of new solutions, as I mentioned, in health, in diagnostics, in agriculture, in all these fields. However, it will take time, and we really need to work on further to find those best solutions, most effective solutions, most cost-effective solutions, as still, let's say, the price of CRISPR application is one of the things that come up, or any kind of side effects, or all the regulatory issues that still are in the way to follow the technology development. So I guess, well, the understanding is evolving. The society is getting more and more familiar with it. And we have to keep on working on that. You know, just several weeks ago in a bus, I saw a sticker with a, you know, with the DNA scissors and you know, the scan the QR code and learn what the CRISPR is. So that's a real impact and education of the society.
And what impact do you think it's had on attitudes within the community as well? Because I feel like it's kind of been all that anyone can really talk about for the past few years, and everyone's going, oh, CRISPR's going to help this, it's going to help that. And what impact do you think it's had on kind of the research community?
Well, I think the research community understood that it's a technology that still needs a lot of development and has to offer a lot of potential of, you know, those different fields. But at the same time, a lot of researchers work on that. So the competition is tough, but at the same time, this competition is very much based on collaboration, because it's still quite a close community, and everybody knows everybody, and are watching quite closely what the others are doing, and this competition, but at the same time collaboration is actually very much moving the research further. So in general, changing a little bit how the research is done and how effectively and how fast. Yeah.
If we kind of look at some of the applications, one of the main ones that obviously a lot of people are focused on is in relation to human health. So what are some of the ways in which CRISPR gene editing can help in that area?
So in human health, the application areas are so vast, so various, and I think, well, it's obvious that the most of the breakthrough are made at the at current stage with the applications which are, let's say, to some extent in a simple form, like, let's say, some vision treatment or some genetic diseases which are quite particular, but all the treatment of various cancer forms and other neurodegenerative diseases, and even application for infectious diseases. So it's just, when we discussed the applications in human health, let's say 6 years ago, there were not so many indications where it can be applied, but this collaboration also with other fields of science and doctors and health professionals really broadens. And the other field in health is diagnostics. Well, CRISPR's application in diagnostics is also really unique, and you can diagnose many things and apply it for really very, very different devices and so on. And well, in general, the industry is growing there, and which, let's say, allows to bring CRISPR to the market way quicker than, let's say, in personalized medicine and human therapeutics.
When I was doing my degree, I remember learning about CRISPR, and it was like, okay, we're going to go in with these scissors, and we're going to cut out these bases, and we're going to solve all of these genetic conditions. How has our kind of capabilities evolved since it was obviously first discovered? Because we weren't going to go from discovering it to immediately being able to fix all these conditions, but how far have we come in our ability to refine this technology?
Well, I think we went quite far by, the CRISPR started from Cas9. Now we have, as I say, all types of CRISPR, all kinds of letters and numbers, and it's still evolving. And we realized that, there are different types of Cas proteins which can be applied for different applications and industries, and it's on the go which types are most applicable for what, and the specialization, and then developments, specific areas. But also we quite overcoming let's say the off-target effect, let's cutting in the wrong place and so on. So we are overcoming very many issues like delivery of CRISPR and so on. So we went really far, but I still think that it's quite a beginning of the path. I mean, that's we are just now realizing that this technology actually has much wider applications. Just we need to integrate it with other solutions, other technologies, and then it gets even bigger impact.
What are some of these kind of other technologies that you're suggesting for it to be integrated with?
Oh, so first of all, I think that application of bioinformatics allows all this selection, characterization, and all kinds of things to happen in a way easier, faster, cheaper form. But I also see a lot of potential in matching CRISPR with all kinds of devices. Because it's the way how we can diagnose things, how we can even treat some of the things. And that's also the part where integration brings a lot of added value. And of course, all kinds of specific delivery mechanisms, if we talk about human health or even plant health and so on, and all kinds of things which help to apply CRISPR in general.
In what ways do you think that CRISPR may or is currently kind of overhyped, and how do you think we can kind of manage people's expectations? Because I know that when all these discoveries come out, people get really excited and then they're like, we're going to be able to do this, this and this. But like, how can we manage people's expectations that obviously things do need time to be refined and things like that?
Well, I think the biggest mismatch in expectations is that, when people are in a real trouble, I mean, when they are really sick with certain genetic diseases and they know that the CRISPR is already applied in this field. That applied, I mean, still at the research stage. They somehow believe that they can come to the lab and get cured, but that's not the case. We still need all this development and clinical trials and so on. And these expectations sometimes really mismatch by the public. So, okay, you are doing so much of the research, so much money is invested, but why we still cannot get it? The other thing is that, it should be available for everybody, but it takes time to make the technology so cost effective that it could be actually applicable for everybody. So yeah, but this understanding of time, it's still, I guess, a mismatch with the society expectations to some extent.
Aside from human health, one of the more kind of interesting and increasingly important applications of CRISPR is within human impact on climate. Would you be able to just kind of discuss the kind of ways in which CRISPR might be able to help in this area?
Well, of course, the climate change and the areas of the climate change and the reasons why we have this situation is so complex. However, there are certain areas where CRISPR can be applied, and CRISPR can be applied to plants. And we see a lot of impact in for the climate because of all this transportation, logistics, because we want to consume certain food products that are grown somewhere very, very far away, or we cannot grow something close effectively. So if we can apply CRISPR to saving certain plant species that, let's say, we had historically in our region, if we can make those species, let's say, less vulnerable, less let's say less eager to sick or something like that. So then we can actually have much more of the production close to us and solve this logistical problem. Also, there are, let's say, possibilities to apply CRISPR for saving certain even animal species that we had historically, the same as with plants. So it's a lot of applications, and also enhancing, let's say, the use of some organic fertilizers and so on. So these little pieces can actually sum up in a very sustainable approach, which can actually have a big impact to climate change.
Yeah, I'm aware of like the kind of like woolly mammoth, like, and that kind of whole revival in that area. But what are some of the like examples of the more, not realistic, but more kind of closer that are going to happen more like quickly? What are some of those kind of like examples that where CRISPR is more likely to be applied soon?
So first of all, as I said, it's for the plants and for developing or certain plant species that can grow more effectively by all means, and what is required in that certain area. So in this case, we can actually make a very big impact, and it's already really actively done.
What is kind of hindering CRISPR being applied in these areas?
Well, the same as with human health, everything needs time. Also, some public perception. The public is still mix gene editing with gene modification, and we have even this joke that something is unhealthy and shouldn't be used because it has genes. So it's a joke that we use because the perception by some of the public is that anything that has the word genes is something wrong. So it's really the lack of education, and but at the same time we need to understand that all applications need investment, and even if the companies are investing to that, they need to see the outcome and some business case out of that, but also have in mind the social impact and so on. So we cannot do all the things at once because already a lot of things is happening. So give us as a society additional 5-10 years, and well, the impact will be way broader and deeper of the CRISPR technology.
I think this kind of association with GMOs like still has kind of a big impact on society. How can we ensure that we educate the public about what CRISPR is and its potential applications?
Well, the education should come from the expert level. I very much believe that the scientists, the researchers should engage into that. They are doing that. However, it's always not enough. Because the more society gets an interest into the topic, the more we need to talk about them. Also to educate kids, that's very important, because if the person grows from the young age with understanding about technologies, with this open mind that new technologies are good, just we have to develop and use them in the correct way, then it really brings the change. So let's say I come from Lithuania, and as I said, we already have a lot of dissemination about CRISPR, even in the public transport, and we have a beautiful DNA sculpture quite close to where I am now, and it's very popular among the young kids, and they play there. They ask their kids what is the parents. Kids ask the parents what is it, and the parents just read what's written there, and they all learn about that. So that's very important, and we really have to tell the arguments why, let's say, CRISPR is important, why new technologies are important, and but that also needs time.
I mean, as kind of CRISPR gets more kind of translated into these various applications, how are we going to ensure that the public are involved in the conversations about what happens essentially with CRISPR? How are we going to engage people in that sense of being not just educating them, but getting them involved in the discussions? Because obviously this is going to have a much wider impact on society.
Well, I would say here, the main role is for the government and let's say governmental and non-governmental organizations, because the research community, they cannot do all. I mean, their job is first of all to experiment, to bring new ideas, to develop them. Well, the society, it wants to understand what is going on, what would be the benefit. However, all this regulation and boundaries and so on, it has to be really the part of the government responsibility, because there are always people who want to push boundaries. Obviously, business is also very often pushing boundaries, but we have to have those regulations. We have to set the rules, to set the limits. Of course, it's hard to set the limits, the same limits all around the world, but still, if the critical mass understands where those boundaries are, then we really can keep those boundaries as much as possible all around the world. And when we have the boundaries, then it's also easier to answer the questions by the society, for the society. So what can I do with this technology? How can I use it? What if I used it for some wrong reason? So no, you cannot do that, because there are limits. I feel that it has to be even more involvement from the governments, from the governmental organizations, not to look only on some specific legislation, but on this philosophical approach. So how we deal with this kind of technologies and how we set up boundaries in our society. So that's very important, and that still needs to be done much more intensively.
I think these kind of policies and regulations, I think that's kind of a massive challenge in terms of the differences across the globe, because people could be using CRISPR for, as you said, like plants or food in that sense, but farmers aren't willing to like invest in that area of research when they can't distribute the food globally, because obviously different countries have different rules in terms of what they consider gene editing and whether or not they'll take that food in. And I think that's obviously a major kind of challenge in terms of translation because of these differing rules. What kind of impact do you think that has, not so much on the research side, but more in terms of trying to then actually translate all of this research into its various applications?
Well, of course, if certain areas in the world, certain geographical areas are more favorable for gene editing application than others, then obviously, business is moving where it has less boundaries. And well, that's also, I think, the essence of the capitalism. Well, we still need to seek that those boundaries, those regulations should be as similar as possible. But that's a very hard agreement to make among governments and among the regions. But you see, if there will be differences, then obviously some areas, some countries, regions will benefit more, and some will to some extent lose. So that's how it always happens. And both business and consumers, they go where they can either do business or consume how they want. So that's the same for CRISPR, the same for many, many other industries and technologies and so on.
Yeah. You're the CEO and co-founder of CasZyme. Would you be able to just kind of tell everyone a little bit about what that is and what made you set this company up as well?
Mm-hmm. CasZyme, as I mentioned at the beginning, is a company working in the gene editing field and development of this CRISPR-Cas technology. And we founded CasZyme in 2017. And our main founder is Professor Virginijus Šikšnys, one of the pioneers in CRISPR field, very well recognized researcher. In CasZyme, we develop the technology and look for Cas proteins which can be applied for very different industries that the companies, our clients and partners in these different industrial areas could then develop final products using the CRISPR technology. So it really varies from agriculture, from research reagents, human therapeutics, diagnostics, industrial biotech, and so on. And our goal is to actually enable those companies to use gene editing solutions for the development of their business and new products.
I think we often view kind of technologies in the sense of like what's going on in the UK and what's going on in the US. But you're from Lithuania. So what is the kind of current landscape in terms of like CRISPR in Lithuania, and what are some of the challenges that exist there as well?
Well, a part of CasZyme, where we work with the CRISPR, we have Vilnius University, a life sciences center, and a very big laboratory of Professor Šikšnys, which works on the CRISPR development from the very various angles, and really very well-known researchers work there, and this area is very well recognized, both here in Lithuania, but it's actually Lithuania is on the CRISPR map as an important player, as a player which contributed really greatly to the technology development and doing that even further. So we even had before COVID all the CRISPR community here in Vilnius. So it's not a question what Vilnius is in CRISPR. And I think that, the challenges are the same for anybody else. It's more of the opportunities that we have here of really educated students and researchers, and all this favorable attitude in the society, because it's the technology that we are proud of. It's the people that we are proud of who worked with it from the very beginning. And it's a great place to be. We have a lot of now researchers, postdocs coming from all around the world to do their research here in Vilnius, Lithuania.
And what do you think the future of CRISPR will look like as well? Or what are you hoping for?
Bright future ahead. Yeah, I mean, really, it has a bright future. Every future has challenges, that's for sure. But I mean, if everybody is on board, and by everybody, I mean research community, business, governments, non-governmental sector, and the society, if we are all on board to have the best impact from this technology, then the future will be bright. I mean, we will use it in the best way that is possible and overcome all the challenges.
It sounds good. I hope it's bright. Thank you so much for joining me today, Monika. It's been really good, and I'm excited to see kind of how this field evolves. I feel like kind of since its discovery, so much has happened, and I feel like it's going to just continue to kind of grow and get better as well. So thank you so much.
Thank you very much.
Hello everyone, if you enjoyed this video, then make sure you check out some of our other videos in our series by subscribing below or going to our website frontlinegenomics.com. I hope you enjoy.